All right, welcome to Geometric Sequences Part 3. And I'm going to dive right into an example. Here it says, determine R, the common ratio, if x, x plus 2, x plus 6, and so on is a geometric sequence. So how do we tackle one with this kind of an abstract start? Well, we just base on what we know. We know that the first term x times r is going to equal the next term. Okay, so that's just the way it is when you're dealing with a geometric sequence. And similarly, if I take the second term, which is x plus 2, and I multiply that by r, that's going to equal the next term. So I go, okay, now, what I've created here are two equations with two unknowns. So that means I can solve them. I just got to figure out a nice, easy way to do it. I think probably the easiest for these is if I go ahead and solve for r. So I can just divide this side by x. Okay, so there we have r equals x plus 2 over x. And then I do exactly the same thing over here. So I go, yep, x plus 6 divided by x plus 2. All right, so if these are both equal to r, why don't we make them equal to each other? And it's really just kind of a substitution here, but I can go ahead and put all this stuff in for r in the other equation, and this gives me one equation with one unknown. And that means I can solve it. I think the easiest way to do this is just to go ahead and cross multiply. So I'm going to go x times x plus 6, and that's going to equal x plus 2 times x plus 2. Okay. Now let's expand out those brackets. So we have x squared plus 6x. And over here, this equals x squared plus 2x, and then another 2x, and then plus 4. Now I can get rid of the x squareds from both sides, so that's kind of nice. That makes it a little bit easier to solve for me, so I just continue that up here. So let's see, what do we got? We got 6x's equals 4x's plus 4. So I'm going to take 4x away from both sides, so that's 2x equals 4. And lastly, I'm going to divide by 2. So there it is. X is 2. Now, when I say there it is, that's great, except it did say determine r. So I haven't actually figured out what r is. So how do I do that? Well, you can go back to either this version, which equals r, or you can go back to this version. And either one should give you the same thing. So if I plug in an x value of 2, let's see here, we can squeeze it down the side here, then r would equal 2 plus 2 divided by 2. So that's going to be 4 divided by 2, which is 2. Now let's just confirm this is doing the same thing. So this is just to check and convince you that either or would be fine. 2 plus 6 divided by 2 plus 2. Well, that looks like 8 divided by 4, and yes, that also equals 2. So either way you calculate r, it turns out that the value of r is just 2. So now, that is done. So the answer is 2. 2 it is for r. Okay, I am going to clear the screen and do my last example. And in this example, we have the following. So we have a population. So whether it's people or some sort of creatures or bugs. But the population is presently 20,000. Okay, so we've got 20,000 of them. And each year, it decreases by 5%. So decreases by 5% each year. Okay. So now the question is, I wonder what the population is in 12 years. In 12 years, what's the population? Okay, so that's our question. How do we do it? Well, I'm going to show you a little trick. First of all, let's just go term by term and see what we have. So initially we have 20,000. Okay? And if we go 1 year, we want to decrease it by 5%. But there's an easier calculation for that. If you take your 20,000, if you want to lose 5%, it's easier to say to yourself, I want to keep 95%. Okay, so losing 5% is one way to look at it, but a more direct calculation is to say, I'm going to take 95%, or 0.95, times 20,000. And that gives me 19,000. So that's, in 1 year, our new population. Okay, it has decreased by 5%. Then let's do the same calculation again. So now I'm going to take 19,000, and I want to keep 95% of it. So I'm going to times it by 0.95. And that gives me a new population of 18,050. And this is to keep going like this, and so on. And what we want to do is see, after 12 years, what's the population. So let me just show you how we would deal with this. There's a couple little tricks that makes life a lot easier. First of all, this 19,000, this is after 1 year, right? So after 1 year, that's our population. So wouldn't it be nice if we kept our sequence kind of in sync with the number of years? In other words, why don't we call this term 1? Because rather than to call 20,000 term 1, this way you know, well, term 1 means the population after 1 year. Term 2 is the population after 2 years. Okay, so it kind of makes it easier because we've got everything lined up and coordinated. So we're kind of starting our sequence here. Okay, and just makes life a little bit easier. So now let's have a look at what we know. Well, if this is where we're starting our sequence, then we know our first term is 19,000. Okay, we know the common ratio, what we seem to be multiplying by each and every time, is always 0.95, right? We take the previous term and we multiply by 0.95 to get the new population. And we know what n is, the number of years, because we want to go 12 years from now, so we want n to be 12. We want to find the 12th term in this particular sequence. We've now got everything we need, and what we're going to do is just put it into the formula and calculate it. So it becomes pretty easy. So I'm going to make a little bit of room up here. Just get rid of maybe this stuff. It'd be nice to keep the sequence there in front of us. So let's see what we got. So the formula I'm using is this one, of course, where it is a times r to the n minus 1. So we're looking for the 12th term, so 12 years into the future, and our starting term a is 19,000. Our common ratio is 0.95, and we're going to raise that to the exponent 12 minus 1. And so now all you got to do is put all this stuff very carefully into your calculator. And if you don't trust your calculator, here's a little tip. Do your power stuff first. Do your 0.95 to the 11, maybe even hit equals, turn that into a number, and then take that number and multiply by the 19,000. That way you're not in any danger of the calculator maybe putting these things together by mistake and raising all of that to the 11. So if you do it in this order, it's pretty safe. So if we do this, I went ahead and did it. Here's what I got as our population. Well, it's 10,000 807, and there's even 0.2 in the population. So there's our answer. In 12 years, the population has dropped down to that many. And that's where I'm going to stop with this lesson.